Good afternoon, everyone. As Mariana mentioned, this was as part of a study from an MSc student, Anel Botes. So the title of this project was The Moisture Loss Studies in Pears, and was a collaboration between the ARC and Stellenbosch University. Now, vapor pressure deficit is recognized as the evaporative driving force for water loss. Now, your fresh produce continue to lose moisture as soon as it's being harvested until it reaches the consumer. There are different environmental factors that drive this moisture loss, temperature and relative humidity, but the amount of water that is being lost is limited or is due to the product's characteristics. For example, what is the cultivar or what is the maturity of the produce? So even though this project consisted of 5 objectives, we will only be looking at one, to investigate the current post-harvest protocols that are followed by certain packhouses. So what we did, the cultivar that was used was Packham's Triumph, and we wanted to monitor what happens from harvest until the end of storage. So we worked with Wolfpack in Wolseley. We identified 2 farms, Laplace and Mostershoek. There were 3 orchards per farm. And then when the fruit was harvested, we put in temperature and humidity loggers within a bin. And then the fruit was stored under controlled atmosphere, followed by 6-week shipping and handling period, which were done at the ARC. CI storage was commercial, so the bins were in a commercial CI room, and then it were also incorporated after shelf life period. So after harvest, CI storage, simulated shipping and shelf life, we did evaluations. We looked at all maturity parameters, which I will not be discussing today. We determined the vapor pressure deficit by using the temperature and relative humidity. And then we focused specifically on the external disorder shrivel. Okay, so these are the results of Laplace in 2019. I will not be showing data of 2020 since we didn't saw any significant differences in severe shrivel. So if you look at Orchard B2 of the CI storage, it had significantly higher levels of moderate, severe, and total shrivel. Moderate shrivel being that it's fruit that had shrivel, but it's still marketable, while your severe shrivel is fruit that can't be marketed at all. So Orchard B2 had significantly higher. After shipping, again, that orchard having the highest shrivel. We saw that Orchard A8A had significantly higher mass loss. And then after shelf life, again, Orchard B2 having the highest shrivel incidence. So what we did then, we calculated the cumulative VPD. So this graph shows the cumulative VPD from 0 until 48 hours after harvest. Up until 20 hours, Orchard B15 had the highest cumulative VPD. And you get a higher, of an exponentially higher VPD when your fruit are being if they're exposed to elevated temperatures, high temperatures for a very long time. But after 28 hours, you can see that the cumulative VPD of Orchard B2 increased exponentially. If we then look at the cumulative VPD over the whole period from harvest until after shelf life, we can see that Orchard B2, which was the orange line, had very high level, the cumulative VPD was very higher. And this coincides with the highest severe shrivel incidence that we saw in this orchard. And then the results of Mostershoek. In this case, Orchard 5J had significantly higher severe shrivel of the CA, also of the shipping, and then also of the shelf life. The cumulative VPD from 0 to 48 hours, we saw that 0.7 increased substantially during the first 48 hours after harvest. But after storage, orchard 5J had a higher cumulative VPD, which again coincides with the higher severe shrivel incidents that we saw. So to conclude, in 2019, we saw significant differences between severe shrivel, in severe shrivel between the orchards per farm. And generally, the cumulative VPD increased exponentially during 20 to 24 hours after harvest. However, this period was longer for certain farms and certain orchards, again emphasizing the very important thing to cool your fruit as soon as possible. Thank you.